Okay, this is the quarter two benchmark video for the review guide. Your first step is to add 1 to both sides, and when you do that, you would get 12. I should divide both sides by 3, and that takes you down to 4. So this would be 3 times x minus 4 is less than or equal to 12. We should divide both sides by 3, so this is x minus 4 is less than or equal to 4. We're looking for two answers. To find your two answers, you would say x minus 4 is less than or equal to 4, and x minus 4. Flip the symbol, negative 4. Two answers would be x is less than or equal to 0, x is greater than or equal to 8 over here, and 0 over here. So you add 4 to that one, you got 8. You add 4 to that one, you've got 0, and we want to put them on a number line. So here is 0, here is 8, it says it's less than or equal to 8, closed dot, heading to the left, greater than or equal to 0, closed dot, heading to the right. These would meet in the middle, so again your answers are 0 and 8 with the corresponding number line. For the second one, you're looking for the decrease. You should graph this, and it is a V. There's 3 units to the left, 1 unit down. You're looking for the decrease. This would be the guy that runs along the line. So he runs from negative infinity to infinity, and along the way this graph switches. So when it starts, it's going down, the roller coaster track decreases as he runs from negative infinity, and as he keeps going, it continues to decrease until he has ran to negative 3. So over this interval of negative infinity to negative 3, the graph has decreased, so you're looking to rate your answer as negative infinity to x to negative 3. For number 3, they're asking for the range. Range is the y values, and to find it, it's over a long period of time. So if you pretend this graph keeps going, it's going to keep going in this direction as we keep expanding it. So the graph is going down, so it would be all of these y values, but as we keep going and going and going and going, it's going to keep going down further and further and further. It would never be above 4, so it's everything from 4 and below it. So the range is y, because we're talking about y values for the range, is less than or equal to 4. The less than is important because it is going down. If it had been going up and over and it kept going up, you would have switched this to greater than. But for this problem, you would say y is less than or equal to 4. For number 4, it asks for the end behavior. It gives you a long equation that you do not know what it looks like, so you have to go to the calculator and graph this to get a sense for what's going on. And when you do that, you get a picture that's kind of smushed together, but it looks something like this. Anyways, this is enough to tell you the end behavior. You don't care about the increase or decrease, so none of these numbers are particularly important. All you're asking yourself is, as x goes all the way to the right, what's the final outcome? Is y going up or down? It's going down. And as x goes all the way to the left, same thing, but in this case, y is going up. To write this, you would say, as x goes to infinity, that is x going to the right, y goes down. Vice versa, as x goes to the left, y goes up. So to do end behavior for something you're not sure what it looks like, graph it in the calculator, and then get a sense for what happens as x goes each way. In this problem, as x went all the way to the right, y went down. As x went all the way to the left, y went up. For number 5, asks us to graph this first off. It's an absolute value, so we're thinking of a V. There's a negative up in front of it, so it's not a V anymore. It's an A or an upside down V, and it's up 3 units. There's no left and right shift, so we're not going anywhere left and right. We're going to go up 1, 2, 3. And instead of making a V, since there's a negative out front, we're going to turn it upside down. So now we have our graph, but before we do that, you also see that it says less than or equal to. Less than or equal to means we need to shade, and in this case you want to shade down because it says less than. If it had said greater than, you would have shaded everywhere else above it. For this problem, the domain is our x values. So we look at this as it keeps going on and on and on and on. So domain is the width of this graph. So as you say, what is the domain over a long period of time? It's going to keep getting wider and it would never stop. So the domain is all real numbers. The range, these are your y values. So now you're looking up and down. So as this keeps going on and on and on and on, it's never going to be above 3, but it would be everything below it. So we should say y is less than or equal to 3. Again, less than because it's going down. If this had been a v and it was going up, it would have been greater than. For the increase or the decrease, the guy starts at negative infinity, and as he starts to run, the graph goes up, and it continues going up. Now he's not jumping, so it never gets to 3, but he keeps going straight across the line. So as the guy runs through this dotted line, the graph goes up until he ran to the number 0. So here he is right here, and now the graph turns around. So remember, your answers for increase, decrease are always x values. The increase in this problem would be from negative infinity to 0, and then it turns around from 0 to infinity and goes down. So the increase is negative infinity to 0. The decrease is 0 to infinity. For number 6, it's a 3-part question. The first part says to translate this into a formula, and it says the volume varies jointly with height and base. So we want to use letters that make sense. Volume would be V equals, and you need to know the pattern or the blueprint for joint variation. It would be K something something, the something something in this case being H and B. Find K in part B, the second part of this, if. Find K if the volume is 400. So we're going right back to this formula up here. Volume is 400. So 400 is equal to K, and then we need to fill in the next two blanks. H is 12, and B is 100. So this is now 400 is equal to 1200 K. To solve this for K, you should divide both sides by 1200. That would be 400 over 1200 is equal to K. Final answer, K is equal to 1/3. So a common mistake people make when going from here to here is they don't include the K in the equation. You need to make sure you bring everything down and solve for the one variable you don't know. For the last part, it says use K to find the volume if, and they give you a height and they give you a base. So we're looking for the volume. So volume is equal to K times the base times the height. We know that K is 1/3. We know that the base is 20, and we know that the height is 9. If you multiply these three things together, you would get the volume is equal to 60. So recapping this problem, you needed a formula for joint variation. In part B, we used the numbers they gave us to solve for K. And in the third part, you use K to find what they asked for in the question. Number 15 asks for the solutions to the equation. You have something that is squared, so your objective is to get everything to the left, set it equal to 0. So you have 2x squared minus 2x plus 7 is equal to 0. You could try to factor this if you wanted, but this particular one does not factor, so that leaves you with the only option of using the quadratic formula. So you should make a box. You should list your A, your B, and your C. In this case, A is 2, B is -2, C is 7. We're going to use the quadratic formula, so negative B would become a +2, plus or minus the square root of B squared would be 4, minus 4, A, C, all over 2 times A. So when you look at this, the first question you should be asking yourself is, how many negative symbols are underneath? And in this case, there is only 1. So you should be subtracting whatever is coming out of over here. So in this case, 4 times 2 is 8, times 7 is 56. So you're looking at 4 minus 56 takes you to a -52. You then want to look at your list of perfect squares, 1, 4, 9, 16, 25. And see if any of them go into 52, and the one that does is 4, and 4 goes into 52 13 times. So this is 2 plus or minus. If we made this 4 times 13, The 4 comes out as a 2, but more specifically 2i because of the negative underneath the root. So 2i root 13 over 4. Almost done. The 3 numbers on the outside, I call them the triangle. They are all divisible by something, and that something is 2. So your final answer is 1 plus or minus I root 13 over 2. For number 16, it wants you to multiply the two fractions. Your goal is to factor, bridge them together, and cancel. So in the top left corner, you would take out a 3, and it leaves you with x minus 2. In the bottom right corner, you have 3 terms. You would factor them by reverse foiling and get x and x. You're trying to get a plus 3 in the middle. Plus 5 minus 2 gets you your negative 10 while accomplishing plus 3x in the middle. Top right corner is the difference of squares. This is x plus and x minus 5. Bottom right corner, nothing to factor there, so that is a 12x. We factored, you bridge them together, and you cancel tops and bottoms. So x plus 5 with x plus 5, x minus 2 with x minus 2. This leaves you 3x minus 5 over 12x. The 3 and the 12 are both divisible. Final answer, x minus 5 over 12x. 4x, excuse me, thank you. X minus 5 over 4x. You got that by dividing our 3 and our 12 each by 3. For number 17, it says choose all equal to negative I. So this might be a slightly different explanation if you're not already in my class, but we go with this chart and we say it's remainder, answer, and we're dividing by 4. So you're dividing each one of these by 4, and if you divide something by 4, the possible remainders could be that there isn't one, 0, 2, 13. So the reason we do the 0, 2, 13 order is that it lines the answers up as 1, negative 1, I, negative I. So there's a longer explanation as to where these come from. But if you memorize this chart, you can kind of just look up your answers very quickly. So for each one of these, this problem asked for equal to negative 1. So if we're looking for equal to, sorry, negative I, not negative 1. If we're looking for negative i's, we want a remainder of 3. So in each one of these choices, I'm dividing them by 4, seeing if it has a remainder of 3. If I divide this by 4, it would go in evenly once, remainder 1. So that one's no good. If I divide this one by 4, it would go in once, remainder 2. No good. This one there's nothing to divide by, but we learned in class that the square root of negative 1 is just equal to I, so that would not be negative I. No good. If we divide 4 into 10, that would go in twice, remainder 2. No good. If we go into 35, 4 goes into that evenly 8 times, which is 32. Remainder is 3. That one's good. And the last one, always check every choice because sometimes there's more than one. If we put the 4 into 39, that goes in 9 times, which is 36. Remainder also 3. So E and F are both correct. So again, to do this, you want to divide the exponent by 4 and then look up the remainder and its corresponding answer from the chart. And the chart goes 0, 2, 13, numbers and letters, plus, minus, 1, negative 1, I, negative I. Okay, for number 18, they want us to multiply these. It says simplify. In reality, this is just a FOIL. So first times first is 6. The outer is minus 4i. The inner is plus 3i. And last times last is minus 2i squared. Combining the outer and the inner takes you to 6 minus I minus 2i squared. The last thing we need to do is know that I squared is equal to negative 1. So if this out here is negative 1, it's really turning this negative 2 into a positive 2. And then positive 2 and 6 takes me to 8 minus I. For number 19, it asks for the increase and the decrease. This is not a function that we are familiar with. So in order to see this, you have to use the calculator and graph it. This is not the exact sketch, but it's pretty close to what your calculator gives you. So when you take a look at it, you should see one increase, a decrease, and then a second increase. So remembering increasing and decreasing is the guy running on the line. This guy runs from negative infinity to 0, and as he does that, the roller coaster track goes up. So you have an increase from negative infinity to 0. I wrote 0. And then the next thing that happens is he keeps running from 0. The graph goes down, and the roller coaster track keeps going down until this guy has ran to the number 2. So now we have a decrease at 0 to 2. And then finally, he's now standing at 2, and the roller coaster track begins to shoot back up. So we have a second increase, and this one is from 2 to infinity. So remember, if you do not know what the graph looks like, we are to use the calculator. You then look at the graph and pretend you have a guy running from negative infinity to infinity. And as he runs across this line, he's always staying right on the x-axis. You ask yourself, what is going with the graph up and down as he does that? Negative infinity to 0, it went up. And then from 0 to 2, it went down. And then to for number 20, it asks you to find the roots. It is something quadratic, so you should slide everything to the left. You would have 6x squared minus 7x minus 3 is equal to 0. This would factor, but it's pretty hard with the 6 out front, so you might want to start right with quadratic formula. So ABC. A would be 6, B would be negative 7, C would be negative 3. So when we use the quadratic formula, negative b, since it's already a negative, is 7, plus or minus the square root of b squared is 49. Remember that b squared is always going to be a positive number, minus 4ac all over 2 times a. Keep going, and we have 7 plus or minus the square root of this should have been a negative 3 underneath, sorry. So C was negative 3. You have 2 negatives underneath, which means you're going to be adding this result. 49 plus, and then the plus over here is 4 times 6 times 3 is 72. When you combine these, you have 121 over 12. You can take this square root, so now you have 7 plus or minus 11 over 12. Notice there is no square root left. You just take the square root of 121 and it gives you 11. Getting your two answers now is 7 plus 11 over 12, 7 minus 11 over 12. 7 plus 11 is 18. 18 over 12 is 3 over 2. 7 minus 11 is negative 4. Negative 4 over 12, negative 1/3. For number 21 in the study guide, it's asking for the apparent zeros. So this graph in your study guide, it's hard to see the actual numbers. They're a little blurry. But the apparent zeros on any graph is wherever your graph crosses the x-axis. So if you have something that looks like this, your apparent zeros, again, are anywhere that it crosses the x. If it does not cross the x in something like this, you would not have any zeros. And if you have something that looks like this, your zeros, again, are only where it crosses the x-axis. You would not want this down here. This is the y-intercept. So on your benchmark or on your SOL, if you're looking for the zeros, roots, answers, solutions, they all mean the same thing. And that thing is, where does the graph cross the x-axis? Okay, for number 22, it asks for the end behavior of a whole bunch of different functions. So for the first one, I only wrote x squared because I know that that means it's a quadratic, which means it's a u somewhere or other, and it's both going up. So to rate end behavior, you're always saying as x goes to the right. So as x goes to the right, here it goes. Where does y go? It goes up. Same deal, as x goes to the left, y is also going up. So anything that's quadratic is easy because they either both go up or they both go down. So as x goes to the right, y goes up. As x goes to the left, y also goes up. Below it here in part C, same thing. It's just there's a negative out front, so your quadratic, wherever it might be, is upside down. So same answer as this one, but they both go down. So as x goes to the right, y goes down. As x goes to the left, y also goes down. Over to part D, this is a line with a positive slope. So if you just sketch any line you want with a positive slope, we can say as x goes to the right, y goes up, and as x goes to the left, y goes down. So as x goes to the right, y goes up. As x goes to the left, y goes down. In the last one, in part B, you might need to graph that one. When you graph negative 4x to the third, you get something that looks like that. So as x goes to the right, y goes down, and as x goes to the left, y goes up. As x goes to the right, y goes down. As x goes to the left, y goes up. So again, end behavior is you're looking as x goes to the right, which is written with infinity, and as x goes to the left, which is written with negative infinity, what does y do? And it either goes up or it goes down, and you can tell this by taking a look at the graph in your calculator. For number 23, it asks you to solve the equation. It is quadratic, so anytime you have something quadratic, it's everything to the left. So this is 6x squared minus 4x is equal to 0. This is two terms, but it's not squares and it's not cubes. So we see what kind of stuff can we take out of this. It's divisible by 2, and the most you can take out in terms of the letters is just an x. That's because this one had 2, but this one only had 1. So you can only take out what they both have in common. To figure out what's left, it's a process of division. So 6 divided by 2 is 3. You had 2 x's, but you took 1 out, so there's 1 left. 4 divided by 2 is 2. You had 1x, but you took it away, so there's none left. You can check to see that you did it right by distributing if you want. If you distribute this back, you would come right back to where you were in the last step. And now the last thing you need to do to solve this is take both things that you have and set them equal to 0. Solving them, divide both sides by 2, and x is 0. On this side, we should add 2 and divide by 3. Add 2 would give you 2. Divide by 3. Your two answers are 0 and 2/3. For number 24, it says solve the system for x only. To solve a system, you're looking to see where these two graphs intersect. And then when it says for x only, so at an intersection point, each point has an x and a y. They're saying that they only want you to find the x coordinate of each solution. So the first thing you need to do is take each equation and solve it so that it's in the form of y equals. In other words, you want to get everything to the right except the letter y, and then you want to do the same thing on the right. So for this first one, I want to get the 3x squared out of there. I want to get the 4x out of there. They're both positive currently, so to get them out of there, it's done by subtracting. So you can say negative y is equal to, we're going to subtract these and toss them to the right. So that's negative 3x squared minus 4x plus 7. I don't want negative y, I want y, so I'm going to divide both sides by negative 1. Y is equal to 3x squared plus 4x minus 7. That is one of them. And we come to our other equation. This was supposed to have set equals 0 in your study guide. We corrected that one in class. So to solve this for y, we're going to subtract 2x over. So negative y equals negative 2x. We, again, do not want negative y. We just want y. So we are going to divide both sides by negative 1. Y is equal to 2x. So now you have two equations. You have to go to your calculator. You turn it on and you go to y equals in the top left corner. You want to graph both of these. And when you do that, I'm not going to be able to show you the exact graph without the calculator, but you would have something that looks like this. You're looking for two intersections, one right here, one right here. To find your intersections, you hit second plus trace, and that pulls up calculate. You want to calculate number 5, the intersections. And to do that, you hit enter twice. So it's enter, enter. You want to line the cursor up. So I say enter, enter, line it up. Line the cursor up with your intersection point and hit enter one more time. So to find your intersections, it's second and trace. 5 is the intersection. Enter, enter, line it up, enter. Gives you this coordinate here. They would give you an x and a y. And then you start the process all over again. Second trace, number 5. Enter, enter, but now we line it up by moving the cursor up here, and then hit enter one more time. You would have an x and a y for this one. The direction said we want only the x values, so the answer to this particular equation would be whatever this x value was and whatever that x value was. Summarizing a system, you solve them both for y, graph them in the calculator, find the intersection, check back to the directions of the problem, and then answer accordingly.